بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 2.3, calculating limits using the limit laws. If limit f of x exists and limit g of x exists when x approaches a, so these conditions are important here, then we can write this. We have limit of the sum equals sum of the limits, and we have limit of the difference equals difference of the limits, and c is a constant multiplied by a function, so we can take it out. So the limit of a constant times a function is a constant times the limit. Also, this is called the product law. The limit of product is product of limits. And this is the quotient law. Limit of quotient is quotient of limits, provided that the limit of the denominator is not zero. If the limit of the denominator is zero, then we cannot do this. Also, if the limit of f of x, for example, here does not exist, we cannot use the product law. Okay, this is an example. Use the limit laws and the graphs of f and g to evaluate the following limits if they exist. Well, we need to find limit f of x plus 5 g of x. So this is by the laws equals limit f of x when x approaches -2 plus I can take the constant out times limit g of x when x approaches -2. So I applied law 1, okay, the sum rule, sum law, and the constant multiple law. Now, how to find limit f of x when x approaches -2 from the graph? This is -1, this is -2. Now, f of x, f is in red. Approach -2 from the right, the function goes to, approach from the left, the function goes to 1. So the limit is 1 plus 5 times the limit of g when x approaches -2. G is in blue. When x approaches -2 from the right, the function approaches -1. And when x approaches -2 from the left, g approaches also -1. So -1. So 1 minus 5 is -4, and that's the limit. Find the limit of f times g when x approaches 1. By the product law, this is limit of f of x when x approaches 1 times limit g of x when x approaches 1. Where is 1? This is 1. F in red. Approach 1 from the right. The function is going to this number, which is 2. Approach 1 from the left. F is going also to 2. So limit of f of x is when x approaches 1 is 2. What about g of x? Well, when x approaches 1 from the right, g approaches -1. While when x approaches 1 from the left, g approaches -2. So this limit does not exist. Okay. So I cannot use the rule, which is the product rule, because the limit does not exist. And our answer would be this limit does not exist. So limit does not exist. Here, limit f of x, we can use the quotient rule and write limit f of x when x approaches 2 over limit g of x when x approaches 2. Well, this is 2. If we approach 2 from the right or from the left, this would be the limit. The function, the red approaches this point, which is, let us say, about 1.4. But the limit of g of x when x approaches 2, now approach 2, the function approaches 0. Approach 2, the function approaches 0. So the blue, which is g of x, approaches 0. Well, if the limit of g of x is 0, then the denominator would be 0, and I cannot apply the rule. So we also say that this limit does not exist, since limit g of x when x approaches 2 is 0. Here you can say also that limit does not exist, since limit g of x when x approaches 1 does not exist. So if one of the limits does not exist, then the whole limit does not exist. More laws. The limit goes inside the power, okay, here. So we can take the limit inside, and the power would be n would be power of the limit. Also, the root, the limit goes inside the nth root. These are laws. If n is even, we don't need the limit to be positive, negative. It has to be positive, of course, because square root or even root of a negative number is not real number. Now look to this law. This is a constant c. So the limit of a constant when x approaches a is just the constant because there is no x here, okay? So the limit of c is c when x approaches a. While the limit of x when x approaches a is just a. So in fact, you are replacing x by a. So the limit would be a, the limit of x. And the limit of x to the power n would be, you can go inside, and the limit of x is a. So the limit of x to the power n would be also a to the power n. And the limit of the nth root of x would be similarly the nth root of a, because the limits can go inside, and limit of x is a. So of course also if n is even, then a must be positive. Evaluate the following limits using the properties of limits. This would be 2 times limit x to the power 2 when x goes to 5 minus 3 limit x goes to 5 of x plus limit of 4 when x approaches 5. As we have seen, the limit of x squared when x approaches 5 would be 5 squared. And the limit of x would be 5 when x approaches 5. And this is a constant, so the limit of 4 when x approaches 5 is 4. So the answer, you add these numbers and get the answer. So 2 times 25 is 50, minus 15 plus 4. So the answer is 39. You do the same here. You can use the quotient rule, okay, and say limit of x cubed when x approaches negative 2 plus 2 limit of x squared when x approaches negative 2 minus limit 1 when x approaches negative 2 over limit 5 when x approaches -2, and so on. So at the end, in fact, you will replace x by -2. Because of all of these rules, it will enable you to find this limit. You just replace x by -2 and find the answer. So it would be -8 plus 2 times 4 is 8 minus 1. So I'll have -1 in the numerator. And in the denominator, I have 5 plus 6. So the answer is -1 over 11. Okay. Plus 2. I'll just check my answer. -2 to the power 2. Yeah, I believe it's correct. Okay. So -1 over 11. We replaced x by -2. So now we mentioned this, that we can evaluate limits by direct substitution. If f is a polynomial function, we have this formula. So we can replace x by a. If a is in the domain of f, also if it's a rational function. So these functions, rational, polynomial, if a is in the domain, they have direct substitution property. And they will be continuous at a. We'll call them continuous at a, and we will mention this in section 2.5. Pay attention that not always, not all the functions, not all the limits can be evaluated by direct substitution. For example, here, if you substitute 1, you will get 1 minus 1 over 1 minus 1, so you'll get 0 over 0. Whenever you get 0 over 0, okay, this means that 1x minus 1 is a factor of the numerator, and there is x minus 1 in the denominator because we replaced 1 x by 1 and we got 0. So if you just factor the numerator in this case, x squared minus 1 can be factored into x minus 1 times x plus 1 over x minus 1. You notice that you can cancel x minus 1 with x minus 1. And now if you replace x by 1, 1 plus 1 would be 2. So the limit of this quantity would be 2. Notice that the function x squared minus 1 over x minus 1 and the function x plus 1 are not equal because this function is defined at 1 while this function is not defined at 1. But they are equal in at any real number except 1. Okay. So to sketch the graph of this function, we will graph this one because they are the same except at 1. If x is 0, y would be 1. If y is 0, x would be -1. And this would be the graph. But this function is not defined at 1. Okay. So at 1, there will be an open circle here, which means that this function, so this line with this open circle is the graph of this function. If f of x equals g of x when x is not a, then they have the same limit, as we have seen, okay? So these two functions are equal, but not at 1. So the limit when x approaches 1 of both of them would be the same, would be 2. Find the limit of this function when x approaches 1, g of x. Well, when x approaches 1, you can come from the right. X could approach 1 from the right or from the left. Well, g of x equals to x plus 1 everywhere except at 1. So they are different only at 1. When x approaches 1 from the right, you will use x plus 1. Because from the right, which it means number greater than 1, so you will use this definition. So the answer would be 2. And if you approach x from the left of 1, if x approaches 1 from the left, then also I'll use x plus 1 because from the left I'll use a number less than 1. So this is also, so the limit is just 2. It is exactly equal to the limit of x plus 1 because g of x and x plus 1 differ only at 1. Otherwise, they are equal everywhere. How to evaluate this limit? Well, if I replace h by 0, I'll have 9 minus 9, so 0 over 0. So notice whenever you have 0 over 0, you can do something to find the limits. You can factor, you can simplify, like here, you can do something. But the limit is not an infinite limit, okay? In this case, the limit is not infinite, the limit is 2. Why it's not infinite? Because we have 0 over 0, not a number over 0. Also, x equals to 1 is not a vertical asymptote because it's not a number over 0. The numerator is 0, the denominator is 0. In this case, we have a hole like this. This open circle is called a hole. There is no vertical asymptote. So notice the difference between a hole and a vertical asymptote. So here also there is no vertical asymptote when h equals 0 because we have 0 over 0. But this is a square, so let us square this binomial. So 3 square is 9. 2 times 3 times h is 6h. H square minus 9 over h. 9 cancels with 9. And you can take h as a common factor from the numerator and cancel h with h. And now you are ready to replace h by 0. So 6 plus 0 would be 6. So this limit is 6. Replace t by 0. 0 plus 9, square root of 9, 3 minus 3, 0 over 0. Once you have 0 over 0, this is t equals to 0 is not a vertical asymptote and the limit is not infinite. You can do something here. Well, I have a square root, so whenever you have a square root minus a number or minus a square root, you can multiply by the conjugate of the numerator. So I multiply by this quantity, which is 1. And now let us see what would happen. Multiply two fractions, so the numerator times the numerator. What would you get? This is difference between two squares if you know the formula. So you will get this times this, which is t squared plus 9, okay, all, or you will square the first term minus the square of the second term. We use the formula u minus v times u plus v equals u square minus v square. And in the denominator, I multiply the two denominators. So I have t squared times t squared plus 9 under the square root, like this. Now 9 cancels with 9. And now you have t squared only in the numerator. So it can be cancelled with t squared in the denominator. And now I have limit of just 1 in the numerator and the square root of t squared plus 9 plus 3. And if you replace t by 0, now you will get an answer. 0 plus 9 square root of 3, if 9 is 3, 3 plus 3 is 6. Because we removed the t and it was the problem. It makes the denominator 0, but it's not anymore exist. So this is the limit. So notice whenever you have 0 over 0, you can do either factoring, like here, or squaring, do algebraic operations, some algebraic operations, maybe adding fractions also, or if you have a square root, multiply by the conjugates. You remember the limit of f of x is L, if and only if the limit from the right equals to the limit from the left equals L, using one-sided limits. For example, show that this limit is 0, absolute value of x. What is the definition of absolute value of x? Either it is x if x is positive, or it is negative x if x is negative. So how can I find, if you replace 0x by 0, this is absolute value, you know? So you need to do something. You need to show that. You need to let x approach 0 from the right and from the left. And if the limit from the right equals from the left equals to 0, then this limit would be 0. When x approaches 0 from the right, we replace x by a number greater than 0. And in this case, the absolute value would be x because the number is greater than 0. And now we can replace x by 0, so the answer is 0. Also, if x approaches 0 from the left, then we will replace x by a number less than 0, and in this case the absolute value would be equal to negative x. And now if we replace x by 0, the answer would be also 0. So the limit from the right equals the limit from the left equals to 0. Then the limit of the absolute value when x approaches 0 is 0. Notice here that if you replace x by 0, you get 0 over 0. Here you get 0, okay? So you can immediately write the answer, but we proved it from the right and from the left. Again, we know the, of course, also, if you know the graph of the absolute value, you should know the graph of the absolute value. When x approaches 0 from the right or from the left, the function approaches 0. Let us approach, let x approach 0 from the right. In this case, we will use a positive number greater than 0. So absolute value of x would be x. And x over x is 1. And remember, limit of a constant, which is 1, is just 1. So the limit from the right is 1. Let us find the limit from the left of this function. Well, in this case, if x approaches 0 from the left, then absolute value of x would be negative x, not x. And negative x over x is negative 1. And limit negative 1 is negative 1. So the limit from the right is not equal to the limit from the left. So the limit of this function when x approaches 0 does not exist. Notice that the graph of this function, if x is positive, then the function equals 1. Y would be 1. If x is negative, the function would be negative 1. And notice that the function is not defined at 0. So this is the graph of this function. When x approaches 0 from the right, the function approaches 1. When x approaches 0 from the left, the function approaches negative 1. And that's why the limit does not exist when x approaches 0. Determine whether the limit of this function when x approaches 4 exists or not. All what we need to do is to find the limits of f of x when x approaches 4 from the right and from the left. Well, if x approaches 4 from the right, then f of x would be square root of x minus 4 because we will use a number greater than 4. And now if we replace x by 4, we get square root of 4 minus 4, which is 0. While the limit of f of x when x approaches 4 from the left would be the limit of 4 from the left, so we take a number less than 4. So the function in this case is 8 minus 2x. And now we replace x by 4. So 8 minus 2 times 4, 8 minus 8 is 0. The limit from the right equals to the limit from the left. So the limit of this function when x approaches 4 exists and equals to 0. If you sketch the graph, also you will find that. The squeeze theorem. If we have a function g of x between f of x and h of x, so f of x is less than g, g is less than h, and if limit of f and limit of h equals L, then the limit of this function, which is in the middle between them, is also L. This is an important theorem and we use it to prove difficult examples like this. What is limit x squared sine 1 over x times 0? Notice that when x equals to 0, this limit does not exist. So we cannot use the product rule here. You cannot say this is equal to limit x squared times limit sine 1 over x. But we know that sine x is always between negative 1 and 1 from the graph of sine. So the graph of sine 1 over x is also always between negative 1 and 1. So we will use this fact to find an upper bound and the limit to put actually this function between other two functions. So this is sine 1 over x. I need x squared. So I will multiply this inequality by x squared. Negative 1 times x squared is negative x squared. And notice that x squared is positive. So if you multiply the inequality by a positive number, it's okay. Nothing will happen. So now we have this function between negative x squared and x squared. What is limit negative x squared when x approaches 0? It is 0. And limit x squared when x approaches 0, 0 squared, which is 0. So the limit of this is 0, the limit of this is 0. So by squeeze theorem, the limit of x squared sine 1 over x when x approaches 0 would be also 0. Squeeze theorem or sandwich theorem, sometimes they call it like this. This is the end of this section. Thank you very much.